Hello guys, today we have the lecture 3 of quadratic equation, and here in theory part we are going to learn what is identity actually. Okay now? So now identity is an equation which states that two expressions are equal for all values of any variables that occurs, such that here I am taking some example that x square minus y square is equal to x plus y into x minus y, and x into x minus 1 into x minus 2, which is equal to x cube minus 3x square plus 2x. Sometimes this symbol, which is known as the identical equal, is used instead of equal to sign to indicate that a statement is identity. Now we are going for the explanation of this statement. So what is identity? What is identity is, and we are going to explain. So here we are going to explain what is actually identity is. Identity means some equations or some statements are given, and it is true for all the variables, values of the variables that's involved in the expressions or equations. So now consider for the explanations, I am taking this one for explanations. Suppose I am taking x plus y whole square. All we know about it, it is nothing but x square plus 2 times of xy and then plus y square. Now this is true for all xy. For all xy belongs to a real number. The instead of x plus y whole square, if I take x plus y whole square as x square plus y square. Now it is also true for infinite values of x and y, where x into y is 0, but it is not true for all values. So here solution is infinite solution presents. We have the infinite solutions, but we don't have every solution. Every pair of x and y does not satisfy it. So it is true for all. It is true for infinite value, for infinite pair of x and y, infinite pair of x and y, but not true for all values, but not true for all values of x and y, not true for all values of x and y. So what we observe that this is true only for the infinite values of x and y, where x and y product is 0, but not true for every values of x and y. So it is not an identity. We say that this value is not, this one is not an identity, whereas you can say that this one is actually identity. Now consider one more examples from the trigonometry. All we know about it, sine square x plus cos square x is equal to 1, and it is true for all values of x belonging to real number, whereas sec square x minus tan square x, it is also 1. So now the question appears, is it true for all values of x? Is it true for all values of x? If I consider x is equal to multiple of 90 degree, does it true? The answer is simply no. Odd multiple of 90 degree does not satisfy. So can we say that it is an identity? Answer is yes. We can say. Why? Because here we are talking about the x, and x would belongs to the domain of the function. Since in the domain of the function tan x, x cannot be the odd multiple of pi by 2. So in the domains value of the function, we have to select the values of x, and for all the values of x in the domain, it is true. So it is an identity. So when we are considering any functions, we have to also check the point where we consider it is an identity and not. That point should belong to the domain of that functions. So since tan x does not have 2n plus 1 into pi by 2 type of points in its domain, so we don't put this type of points in this equation. Okay now, so it is an identity because we see that every points in its domain the relation is true. Every points in its domain the relation is true. Okay now, so now it is an also an identity. My question is, when we say a quadratic equation is an identity, the big question is The big question is here, when ax square plus bx plus c, where this is when this will be an identity, when this will be an identity. Okay, now can we say that it is true for all values of x? No, actually it is not true for all values of x, since it is a quadratic polynomial and the corresponding equation is quadratic equation. We know that domain of the any polynomial is the set of all real number. So domain of f of the function is set of all real number. So it is not true for every real number. So now it is not an identity. Now the question is, if it is not an identity, can we convert into the identity? The answer is yes, we can make it as identity. Now the question is when it will be an identity. Now answer is, if it has three distinct roots, if it has three different roots. Is it possible a quadratic has a three distinct real roots or three distinct roots? Yes, I consider has here alpha, beta and gamma is three distinct roots. So it satisfies the equation a alpha square plus b alpha plus c should be equal to 0. In the place of alpha I put beta, a beta square b times of beta plus c equal to 0. Now a times of gamma square plus b times of gamma plus c is equal to 0. So now I have the three equations 1, 2 and 3. I am going to subtract 1 minus 2. I am doing 1 minus 2. What will I have? A alpha square minus beta square, then b times of alpha minus beta, and that will be the 0. So since alpha and beta are not equal, we can divide. So I am having a times of alpha plus beta plus b is equal to 0. I call this equation is 4. So if I am dealing with alpha and beta, equations, the relations will be a alpha plus beta plus b equal to 0. So now if I have this type of equation, now one subtracting, I am going to do 1 subtracting 3. So what I have in the place of beta, I have only gamma, a into alpha plus gamma plus b equal to 0. This equation is the equation 5. So now if I subtract 4 and 5, what I have actually, if I subtract 4 and 5, I have a alpha plus beta minus alpha minus gamma and equal to 0. So from here we can cancel alpha and alpha. Since we are dealing with the we considered that these three roots are different, so we can say that a beta minus gamma is 0, and here alpha and beta are not equal and not equal to the gamma. So what will happen, this part is not equal to 0, but the product is 0. Only possible we have to say a is 0, but since we are dealing with the quadratic, a cannot be 0. So either you have to say the quadratic has two roots when a is not equal to 0, exactly two root has. But if you say no, I want more than two roots, so you have to claim a equal to 0. If a equal to 0, then 5 gives b equal to 0. So if a 0 b 0, then your original equations, that this one which I call star, so this star will gives c0. So now what I have? I have this kind of equation 0 into x square plus 0 into x plus this 0, which is equal to 0. So now whatever the value of x you put here, it will always be 0, because 0 into something finite quantity is always be 0. So now this will become the identity. So now what do I say, that if a quadratic has three distinct root, if a quadratic ax square plus bx plus c is equal to 0 has three different roots, then it is an identity. If it has three different roots, that means I want to say if a is equal to b is equal to c and is equal to 0, then it will be an identity. So not only 3, if you claiming that it has 4 roots, it is also true. If it has 5 roots, it is also true. So now when ax square plus bx plus c has infinite number of roots, then it is an identity. Infinite number of roots, then it is an identity. And when it is happened, then it is an identity. So when it will become the identity? If and only if A is equal to B is equal to C is equal to 0. That means coefficients are 0. When all the coefficients are 0, then we say that all the coefficients are 0, then we say that it is an identity. When all the coefficients are 0, then we say that it is an identity. Okay, now. So now, can we form a generalizations of these results? Is the generalizations is possible? So now I get the theorem for the polynomial. I consider Px is a polynomial which is denoted as a0 x power n plus a1 x power n minus 1 plus a2 a power x to the power n minus 2. In this way, a n minus 1 x and a n. If Px is degree is n, so if Px has n plus 1 roots, then Px become, this polynomial become, then Px becomes an identity. And it is possible if and only if all the coefficients are 0, a0 is equal to a1 is equal to a2, and becomes a n minus 1 and a n all are 0. Thank you for watching my channel Maths Academy, and I hope all of you visit my website mathsacademy.org.in, where everything is free. Learning is very easy, very simple in the Maths Academy. Okay na? तो मिलते हैं. Now you will meet in the next video, where I have the problem solving video of this lecture. This is the theoretical part of this video, lecture 3. In lecture 4 we will discuss the how to solve questions related to the identity. I hope all of you enjoy this. Now till then, bye, have a nice day guys.